Okay, so starting with angle similarity postulate. Angle. Now, so what I had mentioned is with similarity, only the angles have to be congruent. The sides don't have to be congruent, but all the angles always have to be matching, right? And they have to be congruent. Now, automatically, if these two angles are congruent, would C and H be congruent? Yeah, that's our third angle theorem. But really all you need are those two angles. So we say ABC is similar to FGH. Yeah, Lily, you have a question?
That means that angle A, if angle A was 50, then angle F also has to be 50.
Yeah.
Why did we learn this one?
What's that?
It's so much easier.
So we have three ways,
Why did we do this before?
because we were doing congruency before. Listen, the last lesson was proving any polygon are similar.
No, this
Specifically,
makes so
now
much
we're
more sense.
doing.
So why didn't we do this before?
Okay, it doesn't matter. We're learning it now.
We're doing shortcuts.
You don't say yellow.
Okay. Now, side similarity. These are not congruent. They are proportional. Okay? So, proportional means they have to have the same ratio. Okay, so we say side, and then make sure you put a little similarity symbol next to it so we don't get that confused with side congruence. So, what does proportional mean again? I just wrote it down. Same ratio. So we're comparing each of the corresponding sides. So this over MQ has to be the same as JK over MP, LK over QP. We have to check all three sides. We can't just check two. Okay, so with angle similarity, we just needed two. Here you need all three pairs. And then what's one triangle? We could say JLK or JKL, doesn't matter, MQP. Again, just like we talked about the other day, order matters just like the congruence.
What does like the thing over the other thing mean? Or similar? Like JL
This part is showing,
Oh yeah.
these are showing the sides have the same ratio. That's what we're saying. So we have to compare, like if this came out to a ratio, like an example would be, like let's say this was 8 and this was 4. If this is 6, this would have to be 3, and if this was 4, this would have to be 2. So all three sides, right, this would have to have a ratio of 2 to 1 or 1 to 2, depending on which way you're looking at the triangles. Okay, last one here, side angle, side similarity. So the angle has to be congruent, but the sides have to be same proportion. So here you have to have two sides are proportional, and the included angles must be congruent. Yeah, so here you have to show two sides. It has to be the included angle, just like we have the included angle with side angle, side congruence. So you're going to show two sides. You have to show two sides at same proportion or same ratio. And this here, you have to show this is included angles are congruent. Do you have a question, Alan? Okay, what two triangles?
If I were writing this in a proof, how
Yeah.
would I do that?
Oh, so this is side angle, side. So you would have to show this almost with numbers to prove that they actually, and that's why we don't do this in
Like
a.
RS over XY equals ST over YZ.
Yeah, you'd have to show that those two are equal to each other. And you would have to state that the angles are congruent. Then the triangles are similar by side angle, side similarity. We're not doing proofs, but we are proving with numbers whether they're similar or not. Okay, so here we have our first example. We want to determine whether the pairs of triangles are similar and then state the reason and a similarity statement. So three things. First, well, Okay, we have the three pairs of sides. We have a pair of congruent angles.
The other R is.
Okay, let's see, what are we gonna compare? Let's start with 6.
6 and 15.
Why do we compare it to 15?
Because it's like, you're trying to,
Flip it
basically upside down.
Okay, it's not just upside down. What's the
inverted.
smallest side here?
5.
5. What's the smallest side in this triangle?
12.5.
So we have to compare those.
So-
The biggest side is 8,
Is it?
so we have to compare that to 20. So the middle sides have to be compared, so just make sure you're,
2.5.
so let's take a look. 6 over 15, so we can read, so let's reduce that.
They're similar.
Okay, next we'll check 8 and 20. So we can divide the top and bottom by 4, 2/5. So far, we're good.
Whoa.
Why does it have to go with the best?
And 5 and 12.5. Now, to simplify this, what you can do is multiply, like if, let's say we want to get rid of the decimal, we could multiply the top and bottom by,
By 20.
so that would be 50 over 125, right? If you multiply the top and bottom by 10, that will get rid of the decimal.
Wait, why would it be by 10? I would say.
Because how do you get rid of the 0.5?
Oh, you just multiply it by the point.
And then how many times does 25 go into 50?
2 over 5.
2. 25 goes into, so
2.
2/5, good. So what's the reason? So we're gonna say yes. Side, 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 similarity. You could do side angle side if you also marked these angles congruent, so both could, remember when we'd have congruent triangles, maybe more than one reason you could prove it, same thing here. We wanna put a similarity statement, so that's gonna be triangle, let's say PQR. So which order do we have to make sure? PQR.
Is
STR?
STR, yeah. Okay, so this whole thing is our answer here.
That's a lot of.
Yeah, I know. But we're not doing real proofs, okay? So in a way, this is nicer because we're just,
Are we done with proofs for the year, like new proofs?
right.
So fun.
Okay,
Wow, what are the double?
what triangles would we be comparing here? AEF. Good, and ACB.
Oh.
You see that? Right, so we're gonna compare that little triangle on
But you need
top.
the bottom for the little triangle, right?
Not necessarily, so angle A is congruent to angle A, right? So that's gonna be our included angle. We don't have the third side lengths, so this can't be side, side, side. It also can't be angle, angle.
It could be side, side, side if you
Well, if we
solve for the
knew,
other ones, right?
yeah, but we don't have any information about these two. It's not
Can't
like
you
it's a right triangle. You can't do A squared equals B squared equals C squared.
Okay.
It's not only on a right triangle.
4 and then do 8 over
I
12.
also did that.
Okay, so let's see. 8 compared to the whole side, so 8 over 12.
And then
So that will reduce to
2/3.
2/3. And we're going to compare 10 to this whole side, oops, which is 15.
Thirds.
What if I did it the opposite way, like 12 over 8?
Oh, that's fine. Also gives us 2/3. So we had two sides and the included angle. Okay, so we're going to say yes. Side angle, side.
A is the same angle triangle.
So triangle AE.
If A is used in multiple triangles, then you can count it as itself.
Say that again.
It's actually-
Yeah, that's just reflexive property.
It's like the line, the bisector in the like, through.
Okay, next one.
Well, this one's AA.
All right, hold on, wait a minute.
No.
Let's find the missing angle measure. So far, we only have one pair. But if this is 44, what's this angle at the top have to be?
47. Wait.
Don't they have to add up to 80?
20.
36.
36 or 46?
Wait, the army.
The other one is,
The other one is gonna be 43, so
but still.
right away, I only have one pair of angles, and if I find this third angle, I can clearly see these are not gonna match up, right? I'm not gonna have two angles, so this one's just, so nope. Which is not kind of nice in a way, then there's no work to really do. The only work is to find one of the angle measures here.
That would only work if the other one was, if they were both 60, right?
Wait, which one are both 60?
If both the angles,
The angles?
if A and B, I think we should be both 60.
Well, they don't have to be 60, but
Well, then you could find out that,
if this angle was 46,
yes.
then you would have similar triangles. Okay, here we got parallel lines. So what do we know?
Well, we know the vertical one
Okay, we know vertical angles
and the alternate.
and alternate interior. So it doesn't really matter that we had the vertical angles. With those alternate interior angles, we would have had two. So this is going to be,
You can do two alternate views.
yeah. So remember how I said automatically two?
Can you have angle, angle, angle?
Yeah, right.
Yeah, but it's the postulate is just angle, angle. If you write angle, angle, angle similarity,
Two sides
I'm not going to mark it wrong.
are parallel. They don't have to be congruent.
They don't have to be congruent. Look at these two triangles. Do they appear to be congruent? No, this one's much smaller.
What if it's
But
not drawn to scale?
remember when we did congruent triangles and some people were like, wait, is it angle, angle, angle a congruent statement? No, it's just similar, right? Okay, we need a similarity statement.
Can you say that?
Right, that's not, which one? Triangle what?
I did
XRS, similar to TWS. That's good. Okay.
Do we have to do the?
What do we have to do? We have to do this.
You're not.
That's what it's called.
Here.
It's a study.
It's okay.
But you just do better than me. I would be surprised.
Okay. So let's see here. You want to do Pythagorean theorem?
Yeah.
Okay. You actually,
No, Rosie.
so if we did Pythagorean theorem, 4 squared plus x squared equals 8 squared. Remember, don't forget the c.
Oh, I did it for the bigger one.
Oh, it's oh.
Can I do it for the bigger one?
We
or
could do it
no?
for the bigger one. So we get
What's square root of 125?
5 root 5.
I got x squared equals 48.
X squared equals,
48.
so when I take the square root, this is going to be 4 root 3, because 16 goes into 48 3 times. So, all right, we can actually,
This is already
Okay,
no, I
US.
feel like. 'Cause
you
if the
feel
other
like
one's-
it's now?
If the other one's 5 root 5, well, those have to be constant.
Okay. What?
How did you do that? No, we don't know that because.
This is 4 root 3.
How did you do that?
What am I going to compare 4 to? 5. So 4 over 5. There, I can't reduce that, right? And then I'm going to compare 4 root 3 to 10. Are those the same ratio?
No.
No.
I
So,
told you.
so these are not equal, so our answer is no. Now, technically, we did not need to do Pythagorean
I
theorem.
thought,
Okay, but it's
Why?
nice.
Can anyone explain why do we not need Pythagorean
Could
theorem?
have just used 2.
Okay, what do we notice about this? 4 to 8 is a ratio of 1 to 2, but that's the hypotenuse. This is a ratio of 1 to 2,
That's not the
but that's not the hypotenuse. The 10 would have to be over here, wouldn't it?
You could just notice that video with us.
So I totally would not have noticed that.
Okay, well then that's why we do Pythagorean theorem to
How
confirm.
did you simplify it into 4 and 3?
Square root of 4, that's a bonus. square components if you need help with the simplifying rounded figures.
How is it not the hypotenuse?
It's not labeled as the hypotenuse.
See here.
The 10 was on the side.
No, but the
5 over
A is.
1.
That's the hypotenuse.
That's crazy.
Okay. What are we gonna compare 9 to?
3.
3, because this is the smallest one here, this is
Yeah.
the smallest one here. So 9 over 3 is 3 over 1. We're gonna compare 21 to 7, which also gives us 3 over 1. Again, don't stop with just 2 sides, we have to make sure all 3. So we'll check 25 and 8 1/3. Now, 8 1/3, let's write that out as an improper fraction. What would that be? 25 over 3. So if I'm comparing 25 to 25 thirds, isn't that 25 over 1 times 3 over 25? Remember that trick of multiplying by the reciprocal? Does that work?
Wait.
So the 25 just cancel? Yeah. So I just get 3 over 1. Check. We got all 3 pairs of sides, so we're going to say yes.
So S.
Yes. Side, 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 similarity. And then,
EFD CBA.
which one? DFE. Again, the first one could be listed in any order. DF is the smallest
It's
side.
ABC.
So,
ABC, yeah.
ABC?
yeah,
If
ABC.
you do the 25 to 8.
How do you change a mixed number into an improper fraction?
You multiply the big number by the denominator, then add the numerator, and then the whole number goes over the denominator.
Oh. Okay. All right. So find the value of x.
Are these
Can,
triangles similar?
can we assume the triangles are similar? We have parallel lines, so yeah. These two angles would be congruent, and these two would be congruent, also the vertical angles. Okay. So 2 is going to match up with 5. And good, x minus 1 over x plus 5. Are there other ways we could set up the proportion? Yeah, of course. You could compare 5 over 2, x plus 5 over x. Just make sure that it corresponds, right? Cross multiply. Don't forget to distribute. So 2x plus, oh, okay.
One's like that.
5x.
We should do commodity king.
Promoted to king. Okay. X equals 5. Good? How about the next one? Okay, so 8 is going to correspond to 10. Yeah? And x plus 6. Again, how do we know these two were similar? Well, we already had one pair of angles marked congruent, and we also know vertical angles are congruent. So even though it wasn't labeled that way, we can assume they're similar. Okay, cross multiply. What do we get?
What's 60 minus 24?
36?
So 46. How about 36?
It is 36.
It is 36. Okay. X equals 6.
I love how there's like no definitions, like so like huge definitions on these lines.
This is a much easier chapter. Okay.
Spelled all wrong.
Last page, right? This last page, yeah. Okay. identify the similar triangles, and identify the missing values and measures. Okay, so,
These aren't even the same shape.
okay, again, I know they don't look similar, but what can we see labeled in each of the triangles?
A right
Two congruent angles.
Two congruent angles. So remember,
A.
from the beginning of the year, don't make assumptions based on the way it looks.
Two congruent angles.
Okay, so 3 corresponds to which one?
45.
Wait, which one?
15.
It's got to be 15,
Let's make it.
right?
And then X and 45.
And X and 45.
What's 3 times 45?
90 plus 45.
Yeah, you can also just multiply by 3.
No, it's 135.
You don't even have to do that.
Is that
Look.
135 in case?
What?
What just happened?
What?
Right, can't you make equivalent fractions by making the denominators the same?
Oh.
Why would you want
It's a
to?
lot easier
Why
to.
can't you just wait? I don't.
What's
You can
135?
cross-multiply,
What's
but if you don't have a
135 divided by
calculator-
15?
Is this gonna be a calculator okay test?
However how you
Miss
use it.
Kitson.
We'll see.
Miss
Okay.
Kitson.
Shh. Okay, what 2 triangles are similar?
How do you divide 45 by
ACB
3?
and DE.
D, wait, what did you say, Eden? D,
ACB
ACB,
and DF.
and DFE. Okay, again, you can have those switched around, it doesn't matter.
Amazing.
Good. Okay. Also, if it helps to do the similarity statement first, you can. So like I can write ABC here.
Again, two good angles.
ABC has to be similar to DEF. So yeah, X has to correspond to
5. Oh, X minus 4.
X minus 4. Oh, Oren. Oren.
Crazy.
You're spoiling it.
Oren's crazy.
2x equals 20. Yes, we get 10. Yeah, good.
So what's AB?
So AB is 10. That's easy.
The DE.
And DE?
6.
6. Good.
Okay.
Okay.
Last one.
That's interesting.
If I didn't believe you.
Would I lie to you?
No.
Maybe.
Yeah.
No.
This kid would never lie. No.
I don't like
I don't
that.
believe
Like,
it.
oh, I forget.
Do I strike you as someone who
Or
lies a
calm
lot?
down.
No.
No. You can ask Owen about that. Now, his dad, maybe. Okay. All right, let's see. Similar triangles. We got the little one inside the big one.
ABD
right?
and AC.
ABD and ACD. Oops. CD.
What is?
So it might help, okay, if you have a, oh, I forgot to bring my colored pencils for next class.
Oh no.
So this triangle is similar to this one.
Is it X over 3.5?
So what's the weird rectangle? We have alternate angles.
Literally,
We have
just
alternate
the whole thing
angles.
This is
No.
5, so this is 2.
Okay, so 3 corresponds to 5, right? You see how this is just saying that's the length of that whole side. So 3 has to correspond to 5,
Can't do anything without.
and X has to correspond to 3.5. You see it? Because this is the whole side, that's 5, and this is the whole side here, 3.5.
How do I do the division with the decimals?
Oh, come on, we can do this. Well, what's 3 times 3.5?
It's 10.5.
10.5.
I think that's
I got.
It's 2.11.
Did you get? I think it might be that.
Are we just going with it?
That.
Come on, you can do that.
do you think? 2.1?
Yeah. Think of it as how many times does 5 go into 105?
I don't
Right,
want to
goes
think about
100.
that. I don't
Also,
even
you
know.
Come on, we gotta work on some of those
Also-
mental math skills.
That's 20, it's 21.
Yeah, and then 5 is.
Yeah, that way too.
That's what my elementary school.
When you're
Liam, what's
finding
5
y,
times
can
10?
you just compare it to
Good
x?
idea, but-
Okay, let's do this again. So we know 3.3 over 5 has to correspond to y.
Over y. Oh, I was gonna.
Good, don't forget, it's not just this part that is 3, it's gotta be the whole side, because we're comparing the little triangle to the big one. So it's gonna be y over y plus 3.
Wait, why did you do
Y equals 9 and
3.5? 3 over 5.
Warren, how are you this good?
Why did you compare 3 over 5 to
purposely
y?
go over.
3 over 5, because that's the whole side. X over this side.
Next 9 halves.
Now we're gonna use 3 over 5 again to compare y over y plus 3. Now, could we have used 2.1 over 3.5?
Oh, that's.
Yeah, but why would I want to do that? Work with decimals, right? So what did we get here? 4.5
9
or 9 halves?
Imagine not writing that. It's 4.5.
It doesn't. I missed that. What was it? What was the question?